All right, 12.5 arcs. So yesterday we touched base on the difference between a major arc and a minor arc. What's the difference? Anyone remember? Which one's bigger? Major arc. Major arc is more than half the circle. Minor arc is less than half the circle. So more than half. A minor arc is less than half. Okay, so in a circle, major arc would be something like that. And then the minor arc with that would be like from there to there. That's the minor arc. Okay? Today they'll be naming major arcs and minor arcs. Okay? A major arc is named using 3 letters. So a major arc is named using 3 letters. So for example, in the picture on the right, if I wanted major arc A to E, I have to give a 3rd letter that's in between A and E on that round part. So I would call it probably A, B, E. And then you put an arc over it. So you'd put arc A, B, E. And so the fact that there's 3 letters is telling me that I'm going the long way around. Going A to B to E. Does that make sense? Okay, because if you only list 2 letters, it wants you to go the short way around. And then that would be your minor arc. So your minor arc would be AE with an arc over it. It uses 2 letters. How do you guys feel about that? Major is 3, minor is 2. Major is bigger, minor is smaller. Sound good? A semicircle. What is a semicircle? It's exactly half the circle, right? So it's half a circle. So if you have a semicircle, it's going to go from there to there. It's going to be exactly half. Okay? And then a semicircle, it uses both. Sometimes it uses 2, sometimes it uses 3. It just kind of depends which side of the circle they want you to go on. Okay? Some don't care which side you go on, some do care. So you'll see semicircles labeled with 2 or 3 letters. It just kind of depends on the specifics of the circle. Okay? So 2 or 3 letters. Okay? There's a couple of concepts you're going to use today. Okay? One of them is, in a circle, the central angle will equal the measure of the arc. So for example, if they tell us our central angle is 100, it means the arc out here is also 100 degrees. Okay? The other 2 concepts that they're going to use today, actually it's technically 3. One is that there's 360 degrees in a circle, right? Right? There's 360 in a circle. They'll also use how many then are in a half circle. There's 360 in the whole circle. How many are in half of it? 180. So all the way around, a full circle is 360 degrees. So a half circle, a semicircle, is going to be 180. Okay? And then the third concept they use today is vertical angles. Does anyone remember what vertical angles are? We haven't used them in a long time. Vertical angles, I think they're over here. Over there. Over here. So vertical angles are angles that are across from each other, and they're congruent. So in this picture, do you guys see how this angle and this angle are across from each other? So you need to remember vertical angles are equal. So if this is 100, this is going to be 100. Okay, so is there any questions about kind of those three major concepts? A full circle is 360, a half circle is 180, and that vertical angles are equal. Is there any questions on those three? All right, so let's jump down here and let's just do this first one. They didn't need to do the second one, so let's just do the first one, okay? So this first one says, what is the length of BC? Okay, so they want to know what's the degree measure of BC. What would you tell them? Reagan? 97.4. That's that vertical angle idea, that these angles across from each other have to be the same size. So this one is 97.4. Okay, then it asks for ABC. So, like I said before, semicircles can be 2 or 3 letters. So if I have ABC, how many degrees is that? It's a half circle, it is 180, so that one's going to be 180. And then the final one wants you to find this arc here. I just highlighted it in green. Now, a lot of people assume that it's 52, but are those vertical? They're not. They're not across from each other. Okay? And so the concept you need to use is, find a different, let's use orange, that how many degrees would be from A to C here? 180. And then you need to get rid of these two, right? So you do 180 minus 97.4 minus 52. And so I think that's 36.6 degrees is left for that little piece. But let me double check. Thirty point six, sorry. 30.6 is what's left. Okay? How do those concepts sound? They're okay? All right. So, next we're going to talk about chords. And we're only going to do this first one. That's all they wanted last hour. So when it comes to chords, the first type that they're going to give you is they're going to tell you maybe this is 100 degrees, maybe this is 10, this is 10, and they're going to ask you what that is. What's my question mark? It's 100, right? And so what they're going to do is they're going to leave one of these two blank, and you have to decide, well, is this 10 or is this 100? Well, if each of these are 10, then each of these are 100. Okay? If your chords are equal, your degrees are equal. So that's what it's going to start out as. Any questions on what it starts out with? Then it jumps to a little bit harder, and it gives you pictures like this. Does anyone have any ideas on how we would solve this? Set them equal. Okay, so you're going to set this equal to that. So you get 9n minus 11 equals 7n plus 11. Now on your IXL today, it just has you solve for n. It doesn't have you plug it back in. This one, it actually wants you to plug it back in. But let's solve for n first. So I'm going to subtract 7n. So I get 2n minus 11 equals 11. I'd add 11. So I get 2n equals 22. And I would divide by 2. Find n is 11. So that's what your IXL answer is going to be. It's going to have you plug the number in that you find. Now, this question, though, says find the length of arc SW. So I have to take that 11, and I have to plug it in to SW. So that's going to be 7 times 11 plus 11. What is that? 7 times 11 plus 11 is, should be 88. Right? 77 plus 11. Okay? Do you guys feel like you need more of those? Okay. We're going to jump to this arc length. Okay? There's 3 formulas that you need to have memorized for your next test. Okay, the first one is that circle formula one where it was like x squared plus y squared equals r squared. Okay, so that's the first one. This is the second one, and then the third one is sector length. So for arc length, what it is S equals M over 360, and then C is circumference, so we're going to put 2 pi r there. Okay, so this is one formula you need to memorize. Okay, many of you know what r is. M is the degrees of the angle. So what would your M be in this picture? It would be 36, right? What would your M be in this one? What is that one? Is it 120? 131? So for this one, M would be 131. So it's the degrees in the picture. Okay? Questions on that so far? All right. So then today as you're solving these, they have you leave them in terms of pi. So you're going to plug in your 2 numbers. So my arc length equals 36 over 360 times 2 pi times 16. So you're going to combine your number parts. So I'm going to do 36 divided by 360 times 2 times 16, which gets me 3.2, and then you're just going to tack the pi on the end. So you multiply the number part together and tack pi on the end. Do you feel like you need another example of those? Okay, now as people did the IXL last hour, there was a second type that they came up with. So the second type they came up with is they tell you your arc length maybe is 3 pi. Okay. They tell you your radius maybe is 5, and they want you to find your M. They don't give you your degrees. Okay. So let's plug in what we know. We know our radius is 5. So we have M over 360 times 2 pi times 5. Is everyone okay with that? Okay. This arc length goes on this side. So the arc length they give you is going to go on this side. What happens to your pi's? They cancel. So I get 3 equals, and then I'm going to put my number part together and separate it from my M. So I'm going to write M times 10 over 360. Okay, I got 10 because it's 2 times 5, and then I just moved the 360 over so my number pieces were together. Is everyone okay with that? There's 2 steps left. You're going to times by 360. Timesing by 360 makes those 2 cancel. 360 times 3 is 1080 equals M times 10. And then how do you get rid of your 10? Divide by 10. So M is 108 degrees. Okay? When you get to those, okay, if you need help, just let me know. These types will not be on your test, but they are on your IXL. Okay? So, go ahead, flip to the back. The back is area of a sector. So the area of a sector formula, so this is the third and final formula you have to have memorized for this next test, is the area is going to equal M over 360 times pi r squared. So it's M over 360 times the area formula for your circle. Okay. It's going to ask you to do the same thing. You're going to multiply your numbers together, and you're going to leave pi alone. So for this first one, it's 36 over 360 times pi times 16 squared. Like I said, you're going to take those number pieces and multiply them together. (36 divided by 360 times 16 squared is 25.6 pi. Okay. Again, towards the end of this one, it has the working backwards problems. Okay. So I want to do one of those, and then we're done for today. Okay. Let's say they tell you your area of your sector is 8 pi. Let's say they tell you your radius is 4. And they want you to find your m. So again, we need to plug in what we know. We know we have m over 360 times pi, and then radius squared is 4 squared. Where does your 8 pi go? On the left, right? So what happens to your pi's? Cancel. So you're left with 8 equals m times 16 over 360. So again, I changed it so my number pieces were together. What do I need to multiply each side by? 360. Eight times 360 is 2,880 equals m times 16, and then you would divide by 16. To get 180 degrees. Okay? That's what you're going to see today. If you get to these and you're not feeling comfortable, call me over to help you. These are not on your test. The only ones on your test are ones like this. Okay?